Hello everyone, this is Nilesh here once again. In the previous session, we talked about C# namespaces. And now let us go back to the absolute fundamentals and discuss the basic data types in C#. While discussing the .NET common type system, we talked about two categories of these data types. One was value type, another was reference type. The value type represent directly the value, while reference type will represent the reference, address, and actual values will be stored on the heap in an object. Now you can see that value type examples are int, float, struct, enum. So all basic primitive types, they are value types. While the reference type, as we discussed earlier, class, interface, object, delegate, array, these are nothing but the reference types. The most important difference between the value type and reference type is when we create a local variable of value type, then it will store the value on the stack. And when we create a local reference, then it will store only the address on the stack, but actual object is created on the heap. I guess we had shown that diagram earlier. Person P1 is equal to new person, where P1 address is stored on the stack, but the actual person object is stored on the heap. When you assign one variable to another variable of value type, the whole value is copied. Like here, we can talk with the example. Let's say integer num1 is equal to 1 to 3. And then integer num2 is equal to num1. So putting it diagrammatically, the num1 is a variable. If it is a local variable, then it is created on the stack and storing the data 123. Now num2 will be another variable created, and when you assign num1 to num2, then that 123 actual data will get copied. However, this will not be the case when we go for the reference type. We talked about, like, we can have person P1 is equal to new person, and when then we say person P2 is equal to P1. What is happening in this case? Considering P1 and P2 both are local references, so on the stack we have P1, let's say keeping the address 1000, and my actual object is person object that will be stored on the heap section at the location 1000, right? But when I say P2 is equal to P1, what will get assigned? Will my person object get copied? Answer is no. In that particular case, the P2 will contain the same 1000, and then that 1000 will point to the same person object. I hope that is good. This is the point we are talking about. When a reference type is assigned, it copies only the reference, but for value type, it copies the actual value. We already discussed that the default value for the value types are 0 for integer, for double it is 0.0, for boolean it is false. So these are different values. But all reference types, if they are uninitialized as a class member, by default they will be null. Then the performance. Whenever we are creating a local variables of value type, they are always fast because these local variables are directly accessing the value. However, when we have the local references doesn't contain the person data. It only contains the address. So it need to first go from this local address to the actual person object kept on the heap, and then you can access the name, address, and other information from that. So it adds one extra level of indirection, and that makes the reference types little slower with respect to the value types. Great. So once we understood the basic difference between value type and reference type, let us go back and discuss about the C# primitive types. So C# has got rich set of the primitive values, and you can take a look at, because many of them we had already discussed at the time of CTS. Like we have the byte or short and int, long, float, double, decimal, boolean, char. These are nothing but the C# primitive type, and all these types are typically in the signed range. Signed range means they have the positive values as well as negative values. One more thing that you should be noting over here is the character is 2-byte character, meaning by it is not going to store only the ASCII value, but it is going to follow the Unicode scheme, which makes it ready for all popular worldwide languages, right? And as I discussed earlier, all these data types will be internally converted into the .NET CTS type. Let me talk about one small example. One small example where we are doing simply addition of two numbers. C# code example, I can say. Let's say integer num1 is equal to something, num2 is equal to something. And then I'm making res is equal to num1 plus num2. And then I'm saying console.writeLine res, I'm printing the result. But do you know that exactly same code I can write it in VB.NET language as well? But in VB.NET, there is no int keyword. So how VB.NET code can be doing similar job? Let's say in that case, there is a dim keyword like num1 as integer is equal to something, and you can continue on the same line. Let's say num2 as integer is equal to 7, and you can declare the third variable as such integer, and then I can assign res is equal to num1 plus num2, and finally I can say console.writeLine res. Now do you know that whether you go for this C# code or whether you go for this VB.NET code, in both of these codes, this int or this integer will be ultimately get converted to the .NET CTS type, that is nothing but system int32. Both of these codes will internally converted into the exactly same intermediate language code, and that is the reason they will be offering exactly same performance. Now it is just a matter of the programmer choice whether he is supposed to do programming into the C# language or in VB.NET language. This is the main idea behind the common type system. And one more rule that we discussed at the time of CLS, it was regarding the signed type. As you can note, there are certain unsigned types supported in C#. There are unsigned types available into the C#. However, not all .NET compatible languages support unsigned type. So though C# have unsigned type, though corresponding CTS types exist like system.uint16, uint32, uint64, but corresponding types may not be present into every other programming language. And if I use these types in my program, then there are likely chances that my code will not remain compatible with other languages. So I'm breaking the rules for language interoperability. Well, now as you had got some introduction to the C# built-in type, let us talk about a concept related to the type conversion. Now, here you will see that there are two types of conversion. One is about implicit conversion and another is explicit conversion. Whenever we are assigning from a smaller type variable to a larger type variable. Like if I want to convert one integer to the long, int was 4 byte, long was 8 byte. So while assigning any integer value to corresponding long value, then there will not be any kind of data loss. In other words, I'm going from the smaller type to the larger type. This is also called as a type widening, and this will be automatically taken care by the compiler. You need not to do any kind of explicit typecast. So while assigning one smaller type to the larger type, like int to long or float to double, it will be handled automatically by the compiler. So which all conversions are possible implicitly? This particular table shows you those conversions. So converting from byte to short, int, long, float, double is automatically done. It is a type widening. Another example is int is converted to the long, float, double, or the char is automatically converting to int, long, float, double without any sort of typecasting. This is referred as implicit conversion. However, what if I'm doing reverse? Meaning by I'm assigning a larger type variable to a smaller type variable. This is referred as type narrowing. And while doing this narrowing, there are pretty good chances that certain data may get lost. Certain data may get lost. Like for example, I'm assigning one double value to the integer. If I'm assigning 3.14 double to integer, the 0.14 cannot be stored in integer, and that data will be removed. That data will be truncated. Only 3 will be assigned. But when I write the code only like this, the C# compiler gives error saying that this conversion is not possible automatically, and programmer must provide explicit casting for the same. And it is something similar for the long value as well. You might convert from the long to integer, and that kind of conversion is also not done automatically. You have to provide the explicit cast. Now this implicit casting and explicit casting you need to remember while writing a kind of arithmetic expressions. Typically you need to understand that if you are doing the mix operations, like for example, you are having one short variable and you are adding it or subtracting, multiplying it with another integer value, how exactly the result will be calculated? You need to understand that in such situation, the short value will be first implicitly promoted to the bigger value, and then that bigger value is added into another type, and of course due to that the result will be int, and this conversion will be taken care behind the scene. Being a programmer, you need not to do anything for that. This is very easy, very transparent. But there will be a problem. What if I'm trying to do this addition and trying to assign it to a kind of a short variable? Is it possible? Answer is no, because whenever this calculation will be done, this calculation will be integer. If you are trying to assign this integer to a short variable, this is nothing but the type narrowing, and that cannot be done implicitly. That has to be taken care by the programmer explicitly by putting the typecasting for it. So whenever you are trying to do these small operations, you need to be careful, and that was the main purpose discussing this type widening and type narrowing. Now, whenever you want to do a kind of convergence, how these convergence can be done? Do we always do the casting and that typecasting is enough? In fact, many times just doing typecasting is not enough. While doing the convergence, it is recommended that either you use the convert class or you may use the parse method in the respective primitive classes, like the convert class. I guess we have already used this convert class earlier while inputting the person age. Whenever I'm input the person age, by default, console.readline returns me the string value. And this particular string value, I want to assign it to the age, which is going to be the integer. This conversion can be done by using convert.toInt32. If you have like a long, you might say convert.toInt64. On the similar way, there is conversion option available for convert.toFloat or to double. All these possible permutation combinations are automatically considered over here. But there can be a problem. There can be a problem while inputting a string from the user where you are expecting user entering, let's say 123. But what if user enter ABC? And this ABC you are trying to convert into the number. It will cause the runtime error. It will cause the exception, kind of format exception. Another way of doing it, just now, sometime back, we discussed whenever we are writing int, internally, it is converted into int32. int32 is like predefined .NET type. It is like a class. So inside this int32 kind of type, there is a built-in static method, and the name of the method is parse. What is the purpose of the parse method? The purpose of the parse method is it can take the string input and then produce the corresponding integer output. This is the most elegant and straightforward way of conversion. So if my input string is 123, then my output integer will be 123. This is how the conversion is technically possible. Great. But in this case also, if my input is kind of ABC, which is not really convertible to the integer numeric value, then this will give me the exception at runtime. So this is not going to be possible. This is kind of method is also available in remaining all primitive type like int.parse, long.parse, short.parse, double.parse, float.parse, and these are handy methods converting string type to the other type. Well, but this exception problem is still there. What if I do not want to go for a kind of an exception handling mechanism? If something is failing, I just want to know about it gracefully. If you want to know about it gracefully, then parse is not a good solution for you. Instead of that, you should look for a method called as a TryParse. TryParse is another method available into the int class, or for that sake int32 class. What will happen in this case? You pass the value 123 to TryParse and it will convert it into 123. Since the conversion is successful, the return value will be true. However, if you pass, let's say, ABC to TryParse, now this cannot be converted to the integer anyway. At that time, the conversion is not done, and instead of throwing exception, it will return false because the return value of this TryParse is bool. By the way, then how do you collect the result actual conversion done? That actual conversion done is collected via something called as a out parameter. In next couple of sessions, we will talk about different types of method parameter, and at that time we will discuss about this in more detail. Now I explained you about the different C# primitive types. I talked about the implicit and explicit conversions. We talked about the additional conversion method like convert, parse, TryParse. Now it's time to proceed further with something interesting called as a overflow situation. And better at this point, I will demonstrate you. Just now, I already talked about the range of these data types, like short was having a range minus 32,768 to plus 32,767. What if my calculation result, addition or multiplication, is going beyond that range? At that time, will it assign the correct value or will it give me the wrong result? Let me check it with some example. Let me create a new console application, and in this console application, maybe I can call it as a simple data types. We are still continuing with the .NET 10. Now, let's consider that we have one short value. Let's say num1 is equal to 32,767, which is actually the last number in the range. And then I'm trying to say num1 plus plus. The plus plus will increment the value by 1. You may write it like num1 is equal to num1 plus 1, and it will bring exactly the same result. Now, if I try to print the value of num1, what is expected? Because 32,768 is not within a range of the short. Now, at this time, you will realize that instead of giving you the result positive 32,768, it will roll over to the negative range of the short, and the result will be minus 32,768. Let me set this as a startup project and let me run this. And you see that the result is now kind of negative side. Yes, this is very much possible. But this kind of adjustment, which was done in almost every language like C, C++, and Java, sometimes these changes may not be, these sudden modifications may not be expected by the programmer. And all of a sudden, since it roll over to the negative side, you get the literally unexpected, undesired result. And you might be expecting that if something is not fitting well in the range, why not? It is giving me the error. If you want such error, then C# have a feature for you. C# comes with the keyword called as a checked keyword. You can use checked keyword as an expression, or you can use checked keyword as a block. And in checked block, you can write the similar code once again. Let's say I'm declaring num2 and I'm saying num2 plus plus. Again, you know that this is definitely going beyond the range of the short value. So will it produce the result minus 32,768? Answer is no. In fact, over here, if result is going beyond the range, instead of printing something, it will throw exception in case of overflow. So if I run this application, you will see that I'm getting overflow exception. Arithmetic operation resulted in an overflow. However, if this particular result is within the range, you can run this and you can get the expected output. So C# has got something called as a checked keyword, which will check for the arithmetic exception, overflow exception. On the similar line, there is unchecked keyword as well. However, this keyword is never used practically because the default behavior is unchecked only. If you want it only for sake of clarity or for sake of readability, you might use the unchecked keyword over here explicitly. I hope you got the clarity. Just one side note I want to mention over here. If you ever come from the background of Java, in Java there is a concept called as checked exception and unchecked exception. That concept and this overflow checking, these are two entirely different things and they do not relate to each other. So better you learn this as a different concept altogether. Now that you have understood about the overflow, we can talk about the next thing. Apart from these predefined value types, there are also user-defined value types. Let's say struct and enum. In the next session, we will discuss about struct and enum into the more details. But one common thing that I want to tell you about is all these value types, let it be the user-defined value type, let's say struct or enum, or the predefined value type like int32, int64, single, double, all of them, they are internally inherited from one common class, and that common class is nothing but value type class. So if you ask me about some hierarchy, then I will show you that it is like int32, or maybe I have class, let's say double, maybe I have a class, let's say boolean. All these different value type classes, they are internally inherited from something called as a system dot value type, and then that system dot value type itself is inherited from the C# most base class, that is called as a object class. Please note that object is a base class for each and every class of C# directly or indirectly. If we will talk about the base class, derived class into more details into the upcoming sessions on inheritance. Now we had a brief understanding of all value types. What about the reference types? Going to the reference types. The reference types you will talk about is we have the built-in reference type. I discuss about them while talking about CTS. The primarily 5 types you can consider over here. The built-in reference types are 3. One is an object, which is system.object. Object is also a keyword in C#. The second thing we have is array, and third one is a delegate. And apart from that, we can write the custom reference types. The custom reference types are nothing but class and interface. We already had discussed about the classes in depth. Now, as we will go ahead today, we will also talk about the object type. As I already talked about some special types, like object is one of the special types, system.object, because each and every class, each and every type in the .NET is directly or indirectly inherited from system.object. I already talked about system.valueType. System.valueType is base class for all built-in or user-defined value types. And there is one more special type called as system.void. You might see this at the time of discussion of reflection. Now, this was the comprehensive discussion regarding the C# types, value types, as well as the reference type. As we'll proceed, we will discuss about more reference types like arrays, delegates, interfaces in depth. Now, I want to show you one very special concept over here. Very special concept over here. What if I assign one value type to a kind of a reference type? Let me talk about this. Let me rename this method as main1. Now you know that main1 is not the entry point, and that will never be called internally. And in the same project, for sake of demo, let me create another main. So this main1 is not referred anymore. It is as good as commented. While you want to try this, you may copy the code from that and you can put it into the main and you can try to run that explicitly. Now, if I'm declaring integer, let's say num1 is equal to 123. And as I said that this int is inherited from the value type, which is inherited from the object type. And then we can have the object obj is equal to num1. Is it possible? It should be absolutely possible, because ultimately you are assigning one derived type or child type value to the parent type or the base type. So there is no error. This is very well possible, and compiler do it implicitly without any casting is needed. Let me quickly print the value num1 is equal to num1, and let me also print this value obj is equal to obj. What exactly happened behind the scene? Internally, when we have the variable num1, let's consider that this is a variable on the stack, and let's consider this is a heap area. On the stack, num1 local variable is created and it's storing the value 123. However, the obj is going to be the reference type, and since it is going to be the reference type, it is never storing the value 123 as it is. Then what it is storing? It is going to store the address of the actual object present on the heap. So object present on the heap, let's consider that this is an object type, and this object type will be the copy, or it will wrap up the actual value 123. The value is copied from here to here, and it is wrapped inside the object, while the obj is only keeping the address of the object on the heap. Now, what we achieved with this? With this, we are now trying to treat our value type as a reference type, or in a way, I can say that I'm converting the value type into the reference type. And this particular concept is exactly called as something boxing. It's like we are putting our value inside a box, inside a wrapper, that is referred as a boxing concept. This is really helpful when we want to store the data inside some collections. The .NET collection, flexible collections, which can store any type of object. At that time, this particular feature can be really useful. And in fact, this feature was heavily used during C# 1.0, 1.1, because at that time, all our collections were storing only the objects. So all my primitive type, all my value type have to be boxed, put it into the object, and then that object need to be added into collection. Sometime later, I will show you one demo of it. But then I want to go ahead and I want to do it reverse of it. The reverse of it, where if I want to assign, let's say, integer num2 is equal to obj. Is it possible? Because in this particular case, we are trying to convert one object type, that is a base type, to the derived type, a parent type to child type. Let me tell you, the C# compiler never do it automatically. Implicitly, it will straight away gives you error that you cannot do this conversion. If you at all wish to do this, yes, you can typecast it explicitly, and then this is possible. This can be done, but not directly. But in this case, if I'm writing a code like this, what is happening? At that time, num2 is another variable created on the stack, and that variable, you will get the value wrapped inside obj. My actual value was 123, so that value will be copied back from the heap into the stack. Again, in other words, we are converting from the reference type back to the value type. This particular concept is called as unboxing. Now, though this boxing and unboxing brings some flexibility to you, you can use your value types as objects, which can be useful for certain situations, but this will always bring the overheads in both terms. Overheads in terms of memory and overhead in terms of CPU processing. Because behind the scene, while converting from value type to the reference type, a new object memory is allocated on the heap. And for that conversion, you also need certain CPU cycles. And while accessing it back, definitely you want to do the casting once again. So this casting done at runtime will again have some internal checks carried out by the CPU. And that is the reason, though this is more flexible option, this is not at all efficient operation. Let me quickly show you practically. Like I'm saying integer num2 is equal to obj. And if I'm trying to access num2 is equal to num2, you are seeing that forget about execution, it is giving me compile time error that you cannot implicitly conversion. And if you want, you can do explicit conversion like putting a typecasting. And running this, yes, it will give you exactly same result. And I was then telling you about one case where this particular feature is really used. Though nowadays this particular feature is not common because C# 2 come with the concept called as a generic types. However, before C# 2, people were using this on the regular basis. People were using the non-generic collections, which were treating each and every value as C# object type, C# reference type. I will just show you a very basic, simple level demo. Let's say I can use using system.collections. I'm not using generic collection, I'm using system.collections. And let me write another main. And in this main, let me use a collection called as an array list. Array list is internally the array of objects which can dynamically grow or shrink. Now list.add, and you can add the value 123, which is integer. However, that integer is treated internally as an object by boxing it. And on the similar way, we can add another value, let's say 456. And we can add, let's say one more value, let's say 789. While accessing it back, you can use a kind of for each loop and get the value one by one. Each value you need to again convert it back to the integer, and then you can print these values once again. Though it is working very well over here, please understand that on each time while adding, internally boxing was done, and while retrieving, again converting from the reference type back to the value type, over here unboxing was done. This should have given you clarity about how boxing and unboxing can be practically used for storing the data and retrieving it back. Before winding up this session, again, I want to show you one small comparison. Many times, people try to compare this particular concept with Java's autoboxing. In Java, there is a concept called as autoboxing. And this Java's autoboxing concept is converting the Java's int type to the wrapper type called as the integer type. And there, this boxing and unboxing both are done implicitly. Yes, this particular concept of wrapper classes was added in the Java for the same reason. That is nothing but treating the primitive types as the objects. However, if you try to apply the similar concept into C#.NET, then the boxing and unboxing over here is bit different. Here we are not converting integer into the corresponding int32 kind of type. Rather, we are converting it into the proper object. This is the boxing. and the reverse case is unboxing. Please note that while doing this conversion int to int32, this is not the boxing. In fact, whenever we are writing int, that int is internally converted into int32. So int is a value type. Even int32 is also a value type. There is no conversion. It is just a common type system. The C# type in IL level, it is treated as int32. There is no conversion at all from value type to reference type or otherwise. This kind of conversion is neither boxing nor unboxing. The concept of boxing and unboxing is one of the important concepts. So you can try this and understand it well. In the today's class, we discuss about the data types. We talked about the different categories, difference between value type and reference type. We talked about the C# primitive types. We talked about implicit and explicit conversions. And we also talked about the additional conversion method like convert or parse. We discussed about checked keyword, which will check for the overflow in the primitive type range. And we talked about some reference types in general. And then most importantly, we talked about a concept called as a boxing and unboxing. How the boxing can be useful for converting your primitive value as object, and unboxing has to be done explicitly, converting object back to the value type. I hope you find this useful. Thank you very much.